in 9.2, we're going to look more at rational expressions, and now we're going to look at actually being able to add and subtract them. Okay, and then thinking about what our fraction rules were when we had numeric fractions and applying those to algebraic fractions. Before we do that, we have to look at least common multiple, which has been a tricky subject in the past. The least common multiple of polynomials, you have to find the least common denominator. So the least common denominator is the least common multiple of the denominators. Some steps that we have in your notes for finding the LCM. Factor each expression. List the different factors. Now, sometimes you won't be able to factor if they're monomials, but if they're binomials or trinomials, you'll have to factor them. And if you have a choice on the exponents, you take the higher exponent or the biggest exponent. All right. So let's look at this example right here. Find the LCM of the following monomials. Monomials are single terms. Now, we have multiple variables, but I have three monomials here. So let me get this out of the way here. All right. So what you want to do is I'm going to write down 15a squared bc cubed. You want to use prime factors. Now, what do I mean by prime factors? I'm talking about prime factors of the number or numeric part, or the coefficients. So I can break 15 down into 3 times 5 prime factors. And then I have a squared b c cubed. Okay? I'm going to write down my next term. I'm going to space this out a little bit. And I want to break 16 down to prime factors. Well, that's 2 times 8, but 2 is prime, but 8 is not, so that's 2 times 4. This 2 is prime, but now this 4 is not prime. I can break that down further into 2 times 2. So notice my prime factors, I have 2 to the 4th power, because that's 2 multiplied the other 4 times, and then I have b to the 5th and c squared. Now, you could write it out as 2 times 2 times 2 times 2, but I'm going to leave it with exponents. We didn't have to do that on 15 because it was just 3 times 5. All right, now let's look at the last one here, which is 20 a cubed c to the 6th. We're going to break 20 down. 2 times 10. 10 is 2 times 5. So if I take that, I can write that as 2 squared times 5. Again, 2 squared comes from 2 times 2. And then I have a cubed c to the 6th. All right, so now pull it all together here for the LCM. And listen to the rules. Okay? We set up there, you want to put things in factored form, which we did. We want to take, for the coefficients, we're going to look at these right here. So the coefficients, we want to look at the prime factorization. There and right there. So I'm looking at those for the coefficients. Now, what prime factors do I have? Notice I have a 3, a 5, I have a 2 to a power here in the middle one, I have a 2 to a power over there. So I want to take my prime factor of 2, and now what do I pick? Here's what I mean. I have a 2 to the 4th or 2 squared. You choose the bigger exponents. That's what the rule said, so I'm going to choose 2 to the 4th. Okay, I have right here a 3. There's no other 3 prime factor in any of the other ones, so I got to take that 3, or 3 to the 1st. Now I have a 5 here and a 5 here. They're both to the 1st power, so I take that 5. You know, if I would have had one that was 5 to the 2nd, I would have took 5 to the 2nd. You take the bigger exponent. Now you do the same with your variables. You take all your variables, you take the bigger exponent. So, what do I mean by that? A squared, I don't have an a in the middle one, but I have a cubed here. Take the bigger exponent. So it's a cubed. All right, look at your b's. I have b to the 1st, and I have b to the 5th. You take your bigger exponent for the least common multiple, so I take b to the 5th. I have c cubed, c squared, c to the 6th. What's the biggest exponent out of those? C to the 6th. Okay, the last thing, you can't do anything with the variable part, is to actually multiply 2 to the 4th times 3 times 5. And if you used a calculator and did that, you should get this to be 240 a cubed b to the 5th and c squared. So the 240 comes from multiplying out the 2 to the 4th times 3 times 5. So that's kind of the rule you have to do for LCMs, and that's with monomials. Break down the numbers or the coefficients into prime factors. Okay? Alright, for some reason I had that slide in there twice. Alright, now let's look at when they're polynomials. Notice what you need to do. Factor completely first if you have more than one term. Binomials or trinomials. So, we're finding the LCM of these two right here. Notice they both have 3 terms. You want to factor completely. You got to use all your factoring rules. So, if we look here, if I look at this first one, the one on the left, first thing I notice is I can take an x out of all the terms. That's always what you ask yourself. Okay, so then I'm left with x squared minus x and minus 2. Taking an x out, opposite of the distributive property. But you need to factor completely. What do I mean by that? This right here, trinomial, probably is factorable. X and x, I want factors of negative 2. Well, that's 1 and negative 2, or 2 and negative 1. And I want them to add up to negative 1. That would be this pair right here. So it's a plus 1 in one of the binomials and a minus 2 in the other. So here is the first one in factored form, or factored completely. Now I look over here. I can't take an x out on this one, so I'm going to go right into, okay, is it a trinomial that's factorable? And it probably is. Factors of 4, 1 and 4, 2 and 2, but I don't really need my positive ones. The signs are the same, but they're going to be negative. So negative 1, negative, I can kind of ignore the positive ones. Negative 2 and negative 2. Which pair add up to negative 4? Negative 2 and negative 2. Now, here's what you need to notice. That can actually be written, and you need to do this if you're finding the LCM, as x minus 2 squared. You want to write it with a power. The only way that happens is if the two binomials are the same, you can write it as a power of 2. Okay, so that was a perfect square trinomial that can be written as a binomial squared. So now, when you're finding your LCM, I want to use all my factors. My factors are now what I have in parentheses along with this factor of x on the first one. So I've got to use my factor of x. I've got to use my factor of x plus 1. Now I have this. Here's what I want you to notice. I have an x minus 2, that's to the first power, and then I have an x minus 2 to the second power. Just like we did it with the monomial ones, you use the bigger exponent on your common factors. Okay, there it was just like a common variable or the common number. Here it's x minus 2 to the first or x minus 2 squared. Well, I'm going to use x minus 2 squared. There is my LCM of those polynomials. Factor them first, and then use all your factors, bigger exponent if you have a factor that is raised to a power bigger than 1. Alright, now let's get into actually adding and subtracting. Remember the rules, okay, for adding fractions. So let me just kind of go through this. 2/3 plus 3/5. When you were adding, and you can't use your calculator here with algebraic fractions, so you got to know how to find common denominators. Common denominator would be 15. Okay, it's 3 times 5, the least common denominator. So I multiply by 5, so I multiply the top by 5, that's 10. On the bottom, I'm going to multiply by 3, I multiply by 3, so that's 9. Now I add my tops, so it's 19/15. That's kind of what they're showing right up here. Algebraic fractions are the same way. So let me go through this. A over C plus B over D. So we'll just start out with some real simple ones where we're using 4 different variables. Your common denominator, and usually with algebraic fractions, I say, okay, my common denominator is, well, let's separate it into 2 fractions on this first one, and then I'll show you what we do later. So my common denominator, or my LCM of the denominators, is actually, I need my factor, my variable C and D. So I'm going to do CD on this one, CD on this one. Now, what do I multiply C by to get CD? Well, I multiply by D. So So I multiply by d on top, so it's AD. You're not doing anything different than you did for numeric fractions, except for you're getting variable expressions. Here I multiply by c, so I multiply the top by c, so it's plus bc. So now I get my common denominator of CD, just like over here when it was 15, it stayed over 15. Now, when I actually added the tops here, I could put 10 plus 19 together, or 10 plus 9 together and get 19. Right here, you have AD plus BC. You cannot put those together. They are not like terms. AD is an AD term, BC is a BC term. That would be as simplified as you could go. Now, you can't go and like cancel these C's. You know, the C from this term with the C on the bottom, because there's more than one term. Or you can't cancel the D from the first term with the D on the bottom, because of the add sign between the two terms on top. Alright, so let's go down here. I listed some steps for you, so pause the video if you need to get those down in your notes. You need to get a common denominator, which is the LCM, or lowest common denominator. Okay, multiply the numerator by what the denominator needs. These are just kind of the steps with how to add and subtract fractions. Okay, add or subtract the numerators depending on what the sign in the middle is. All right, so let's actually sorry about that. So let's actually extend the page here a little bit. And let's erase my little highlight that got on there. Alright, watch very carefully here. Now, if what you want to notice is when you're adding these fractions, there's a monomial. So basically we have a single term and a single term. We don't have to do any factoring on these, and we'll get to those later in this lesson. Notice single term, single term. So we need to find the lowest common denominator. Okay, so I'm going to do some work off to the side here. 6b. Think about what we did earlier in the lesson. 6 can be broken down into 2 times 3. Okay, I want to find the smallest number that 6 and 14 go into. Okay, so 2 times 3 times b. And I'm going to do 14 a squared b squared. That's my other one. I'm trying to find the LCM, or lowest common multiple of these two. 14 is 2 times 7, and then I have a squared b squared. So if I'm finding the LCM, which is the common denominator, lowest common denominator, think about your rules for LCM that we just talked about earlier. I'm going to use all my factors. So I have a factor of 2 here and 2 here, so I need that factor of 2. They're both to the first power. I have a factor of 3 in this one, so I need that. I have a factor of 7 in this one, so I need that. Alright, now, I only have a squared in the bottom, so I need the a squared. I have a b here and a b squared here. You take the bigger exponent, so I take the b squared. Now, to actually find the common denominator, I need to do 2 times 3 times 7, so that's 6 times 7, or 42 a squared b squared. So, you could have listed out multiples of 14 until you got to one that 6 also went into, and that will work. You know, if you go 14, 28, and then 42, oh, 6 goes into that, so there's my LCM. You could do it that way, but this method that I just showed you always works. So here's what I suggest you do. Our LCM, or our common denominator, is this. We're going to write it as one fraction. I'm not going to keep it as 2 fractions, but now you need to look individually at what each fraction does. So I need to say, okay, what do I multiply 6b by to get 42a squared b squared? So I need 6 times 7, and then I need to do a squared, because I got to get a squared, and I had a b, so I need to multiply by b to the first to get my b squared. So I'm going to multiply by 7a squared b. This right here. So what does that leave me with? Well, that leaves me with 35 a to the fourth. Now, where does a to the fourth come from? If you look right here, I've got a squared and a squared. That's where a to the fourth comes from. And then I have the b. Okay? Alright. I'll use a different color here. But now I want to look at this one. What do I multiply that by to get my common denominator of 42a squared b squared? Now, 14 times 3 will get me the 42. I already have the a squared b squared, so I'm not going to put any variables after the 3. I don't need to multiply by any of the variables. So I'm really just multiplying by 3. 3 times that 14a squared b squared gives me 42a squared b squared. So now I do 9 times 3 here. There's a plus sign in the middle, so it's plus 27. And that is your answer. Now, I cannot, and this is very key, you cannot go and start canceling there because there's more than one term up here on top. Okay, so let me hit undo on that. Okay, if there was just the one term, then you can cancel. But because you have that plus sign in the middle, you can't start canceling from one of the terms, stuff that's on the bottom, in that one term on the bottom. That's as far as you can go. Okay, so if we go over here, now I want to find my LCM or my LCD. What's the common denominator? Now with this one, with 2 and 12, 2 actually goes into 12. So 12, remember, it can be one of the numbers if the smaller one goes into the bigger one. Okay, and then I need my variables. I need the x because of the x right here. And I have y or y squared. I use the bigger exponent, so it's y squared. Okay, so here's what I want to do. I want to write over 12xy squared. Now, what do I multiply by? And this is absolutely key, and you got to show this work. 2y times what will give me 12xy squared? Well, I need to multiply by 6 to get 12. And then I need to multiply by x because there was no x in that denominator. I only had y to the first, so I need to multiply by y. So I'm really going to multiply by 6xy. So if I actually multiply 6xy times my 3x squared, I get 18 x to the third y. Okay, on the second one, notice I had 12xy squared. That is my common denominator. So multiply by 1, that doesn't really change it. So I'm going to get plus 5 times 1, or just 5. Okay? I can't go any further than that. I end up with those two terms on the top over the 12xy squared. You cannot cancel like the x on the bottom with one of the x's in the 18x cubed y term because of the plus sign in between terms. There's more than one term on top. Okay, division doesn't undo addition. Okay, so that's why you can't cancel there. Alright, I think I will finish up the lesson in part 2 of this video, so I'll stop